Good afternoon, everyone. Myself, Jamendra Singh from Chemistry Department of Deshbandhu College. We are in room number 5. Let us start the introduction of our chairperson, Dr. Leena Agarwal. Leena, ma'am, are you there?
Yes, sir, I am there.
Thank you, Leena, ma'am. Dr. Leena Agarwal completed her BSc in Chemistry from Hansraj College, University of Delhi, and MSc from IIT Delhi. She received her PhD from Department of Chemistry, University of Delhi, and she has many publications in reputed international journals. Currently, she is working as an assistant professor in Department of Chemistry, Netaji Subhash University of Technology, NSUT, New Delhi. Her research work mainly focus on computational studies of protein water system using statistical theory and a molecular dynamic simulation. Welcome, Leena ma'am, on the behalf of ICHE conference. We are welcome to you.
Thank you, sir.
Now, there are some rules of the presentation. The presentation will be of 10 minutes. उनमें 7 मिनट में आपको अपना present करना होगा, and there will be 3 minutes of discussion. So every participant should keep in mind कि 10 मिनट से ज़्यादा ना हो आपकी. Let us start from our very first presentation. Presentation code PV22. It's P Jyotirmay.
Yes, sir.
You can start your presentation.
Yes. Sir, I'm not able to share my screen.
Yes, there is any problem?
I'm not able to share my screen.
We are not able to share a screen. Let's try once again.
Sir, actually it is written host disable participant screen sharing.
What is the issue? It's showing there.
Host disabled participant screen sharing.
No, now you can try it. We have enabled it.
Is it going, sir?
Yes, it's visible now.
Good afternoon, everyone. Myself, Jyotirmay. I'm a research scholar from Department of Botany, Centurion University of Technology and Management from Odisha. I'm working under the guidance of Dr. Gyananjan Mahali. My presentation topic is...
Mate, I think you have joined from 2 devices. That's why your voice is... There is some problem with your voice. Is it that you have joined from 2 devices? Okay, now you can start.
My presentation topic is pharmacological values of black turmeric, preserving and expanding indigenous knowledge base. Starting with the introduction, black turmeric is also known as the Curcuma cassia, is a traditional medicinal plant that heals many ailments from the ancient times. It has many functional components which contributes to its pharmacological values. This endangered species is found along the central eastern coast of the Bay of Bengal. Therefore, to preserve and protect its existence and the therapeutic values, efforts are being made to protect and conserve it. Then comes the material and methods. I have done the collection of samples from 3 different geographic regions of Odisha. After that, it was maintained and preserved well in the study area climatic condition. Then the fresh rhizome and leaf sample was collected. The rhizome and leaf extraction was done after drying process using polar and non-polar solvents in succulent apparatus. The extraction was collected and preserved well for further analysis. After the screening process, methanolic extract was selected for further analysis. Then phytochemical analysis was done, that is both qualitative and quantitative. Then the extraction was analyzed by compound characterization, that is for XRF and FTIR. Then after that, antibacterial activity was conducted against 8 human pathogens using this diffusion method. At last, anti-cancerous activity was conducted by taking cell line MCF7 through MTTSC. Now the result part, moving on to the result and discussion. As we can see, the rhizome and leaf sample was collected. The extraction was done. After that, phytochemical analysis was conducted. Then XRF analysis was done. In XRF analysis, in case of methanolic rhizome extract, phosphorus is present in highest quantity, followed by the silicon. While in case of leaf methanolic extract, sulfur is present in highest quantity, followed by gluten. This difference in structure, soil type, cultivator area, plant age, environmental condition, and irrigation methods are the primary causes of this variation in elemental concentrations. Then FTR analysis showed the presence of organic compounds such as hydroxyl group, amino group, lipids, aliphatic compounds, aromatic compounds, halo compounds, and many more. After that, antibacterial activity was conducted using diffusion method by taking 8 different human pathogens, that is Salmonella typhi, Pseudomonas aeruginosa, Staphylococcus coagulus negative, Vibrio cholerae, Escherichia coli, Serratia marcescens, Staphylococcus aureus, and Klebsiella pneumoniae. In the result of antibacterial activity, rhizome methanolic extract showed highest zone of inhibition against Escherichia coli and Serratia marcescens, that is 20 mm, while leaf methanolic extract shows highest zone of inhibition against Staphylococcus aureus, that is 18 mm, followed by Salmonella typhi, that is 17 mm. Lastly, anti-cancer activity was evaluated by MTT assay using MCF7 cell line. It was observed that in rhizome sample, IC50 was 107.2 μg per ml. That is, 50 inhibition was found at this concentration. In case of leaf sample, IC50 value was only 93.7. Then, why it is the need of, that is my future work, or why it is the need of this research? The black turmeric based traditional knowledge can be integrated into modern healthcare system and can lead to the development of hybrid treatments that combine the best of both the traditional and the modern medicine. The future holds promise for the discovery of new drugs and therapies by studying and validating the efficacy of these traditional remedies. How we can conserve the knowledge, that is for documentation part, the research and validation, then we can give the education and training, then we can integrate with the modern medicine, then it can be useful in the different drugs medicine, and it can be useful for bioprospecting and drug discovery. Now I will conclude my presentation by stating that methanolic extract of both the rhizome and leaf showed better antibacterial and anticancerous activity. Presence of phytochemicals makes it a potent hub for many clinical treatment and drug discovery. Thank you.
Okay, so my question is, first of all, your voice is not clear. Okay. Okay, so which polar and non-polar solvents have you used?
Ma'am, I have used only methanolic and NXN. For non-polar, I have used NXN.
Okay. And hexane. Okay. Here you have concluded like methanolic extract of both rhizome and leaf belonging to black turmeric showed better antibacterial and anticancerous activity. So it showed better antibacterial and anticancerous activity as compared to
NXN.
As compared to N-hexane. It means in the polar solvent, this black turmeric is showing better antibacterial activity. Is it
Yes,
like that?
Yes, ma'am.
And what are your conclusions from FTIR? Just the functional groups or some other conclusion?
No, just the functional group.
Okay. And what does that indicate? More sulfur and more phosphorus?
This indicate the presence of plant that मतलब सॉइल से वो कितना लेके आ रहा है, मतलब एलिमेंट्स पूरी डिस्क्राइब करता है एक्सटर्नल.
So does this more sulfur content or more phosphorus content of, I mean, can you relate it with this pharmacological value?
Yes, ma'am. As the ब्लैक टर्मरिक ऐसा अवेलेबल नहीं होता है मतलब हर जगह, तो इसीलिए हम लोग क्या करते हैं कि मतलब उसको ये क्लाइमेटिक कंडीशन में हम लोग पहले उसको अडॉप्ट करते हैं. इसी सॉइल के साथ हम लोग उसको पहले मतलब उसको ग्रो करते हैं. तो उसी सॉइल के साथ हम लोग उसका प्लांट एक्सट्रैक्ट को हम लोग डिफरेंट करते हैं कि वो कितना एक्सट्रैक्ट ले, कितने एलिमेंट्स ले पाता है. तो वही एलिमेंट्स जैसे फॉस्फोरस एनपीके जैसे यूजफुल होता है ग्रोथ के लिए, और ग्रोथ होने से उसका यील्ड भी ज्यादा होगा. तो यील्ड ज्यादा होने से हम लोग उसको डिफरेंट फार्माकोलॉजिकल एक्टिविटीज में यूज कर सकते हैं. क्योंकि इसका जब जब हम इसका एक्सट्रैक्शन कर रहे हैं, इसका क्वांटिटी बहुत ही लेस आता है, तो इसीलिए हम लोग उसको ज्यादा भी ले सकते हैं और इस हिसाब से ऑर्गेनिकली ग्रो भी कर सकते हैं.
Okay. Okay. Thank you. Next is Naveen Kumar.
Hello. Hello.
Yes, the next presentation of code number PV23, Naveen Kumar.
Hello. Hello. Are you audible?
Yes, yes, you are audible.
Yes. Hi. My name is Naveen. I'm from BHU Department of Chemistry, and my topic is a multi-component reaction of CS2 amine and sulfoxamide in water. Straightforward access to beta-keto dithiocarbamates, thiazolone 2 thiones, and thiazole 2 thiones. Introduction.
Naveen, present your
Yes,
poster.
Present here also first.
Okay.
Naveen, do you know how to share a screen?
Yes. My poster does not display on screen, sir.
But we allow to all the participants.
I
Just
try,
try.
sir. Can you display my poster? I mail you. Hello.
What is the problem there?
Sir, I cannot connect with my poster in display, sir.
Just you have to wait. We will give you the chance to do the last one. We will start with the next one. The code number PV24. नवीन आप वेट करिएगा, लास्ट में आपको हम कराएंगे.
Okay.
The next code is PV24, Shreya Sharma.
Yes, sir. Am I audible?
Yes, you are.
Okay, let me present my poster. Just 1 second. Can you see my poster?
Yes, it's visible.
Okay. Just 1 second. So, yeah.
It's visible, Shreya. Now you can present.
Okay. Good afternoon, everyone. Today I'm Shreya Sharma from Birla Institute of Technology, Ranchi, going to present my poster on the topic fabrication and analysis of polyvinyl acetate grafted amphiphilic graph copolymer, and to explore its solubility enhancing and tissue regeneration application under the guidance of Dr. Trishna Ball, my guide. So, come to the introduction. Graph copolymers are basically polymer structure with one or more blocks which are connected to the main polymer chain. They are type of polymer that has a polymer chain as backbone and another chain of polymer as side grafted part. So, in the structure of graph copolymers, the hydrophobic and hydrophilic balance can be controlled by altering the density of relative grafting between the backbone hydrophilic polymer and grafted hydrophobic polymer. Here we have utilized a natural polysaccharide neem gum to synthesize an amphiphilic graph copolymer with the microwave assisted technique. Coming to the methodology, first we isolated the powdered neem gum polysaccharide from true neem gum. It was taken and dissolved in aqueous media, and after dissolving the neem gum polysaccharide, we added the monomer. Here we have taken polyvinyl acetate as our hydrophobic monomer, and it was stirred for 30 minutes at 60 degrees Celsius. After that, we added ammonium persulfate as an initiator to initiate the chain reaction, the free radicals, as we can see in the scheme also here. And after that, the mixture was microwaved for 150 seconds, and there was a cooling and heating cycle for 30 seconds. It was microwave for 30 seconds, then put in ice glass for 30 seconds, and the cycle was repeated for 150 seconds. The final product was poured into excess amount of acetone to remove any homopolymer left and to terminate the polymerization process. Then the precipitate was collected and dried, and various grades were formed. As you can see in the resultant discussion table, various grades were formed using different amount of monomer, different amount of the initiator ABS, and then we selected the best grade, the optimized grade on different things like fees, the yield, percentage grafting, interesting viscosity, on different factors. The percentage grafting was calculated according to this formula, and after that we came to a conclusion that the sixth grade, which showed the highest amount of yield and percentage grafting. After that, the optimized grade was went for various analytical characterization so that we can confirm if the grafting has happened or not. As we can see in the FTIR studies, there is one graph for the pure neem gum, and the other one is for the prepared amphiphilic graph copolymer. Some characteristic peaks like OH stretching can be seen in both at like 3 centimeter inverse in the neem gum, and again in also the amphiphilic graph copolymer. And there is a peak at 2,124 centimeter inverse, which is due to overtones of CO structure, and at 1620, which responds to amide groups present in the neem gum. Coming to the amphiphilic graph copolymer, there is a peak at 1720, which attributes to carbonyl group absorption peak, and at 1454, there is a peak of CH value vibration, which of CH3 group, which is a characteristic peak for vinyl acetate, this which indicated the grafting. Also, then we went for solid state 13 CNMR studies. Then in solid state NMR studies, we observed a upfill shift from 172 to 176 ppm. A 4 ppm shift was seen, which mainly due to the C double bond O of the polyvinyl acetate monomer. Other downfields from carbons also can be seen which indicates the anomeric carbons and alcoholic carbons. After the NMR spectra, then we wanted to understand the amphiphilic nature, if the amphiphilic graph copolymer is showing any surfactant-like activity. We went for critical missile concentration analysis. Here we have used surface tension method to measure the CMC. Like we kept increasing the concentration of our polymer, and with increasing the concentration, the surface tension keeps decreasing. But then there comes a point when it becomes constant, and that point is known as the CMC value, the critical missile concentration value. And this was found to be 0.27 milligram per ml, which is a very low value, indicating better stability of the structure. And if the hydrophobicity increases, the CMC value decreases. So this also indicated the nature. To understand its biocompatibility, we went for bactericidal studies and hemocompatibility studies. In bactericidal study, the zone of inhibition was seen, and this was shown against the gram-positive bacteria, Staphylococcus aureus, and the zone of inhibition was around 1.3 and 2.1 for neem and the amphiphilic copolymer. After the bactericidal studies, we went for hemocompatibilities. In the figure, we can see there is a negative control, positive control, and a test sample. The test sample showed hemolysis. Basically, we do hemocompatibility to evaluate the damage any materials can cause to the cells. So biomaterials mostly considered safe if they have the hemolysis value less than 2%, as per the ISO 109.
They kindly conclude it.
Okay, so it showed 0.65% hemolysis. So we concluded that this is a biocompatible. After that, we went for solubility studies, and the solubility studies with the amphiphilic graph copolymer showed 10 times 10 times higher than the amount of aqueous medium without the amphiphilic graph copolymer. So the solubility increased 10 times of curcumin. We have taken curcumin drug here, which is water-insoluble drug. And finally, we went for the tissue response, for which we observed in lean process for 15 days. And the hair follicles and was observed in loss of keratin layer, which indicated healing. When we investigated the histological evidences, we could see cell growth, enhanced fibroblast cell growth, and granular tissues. And the density of collagen was also much higher in the test sample mice than control mice. So to conclude, I would say that it showed biocompatibility, and tissue collagen and fibroblast growth in mice suggested the application of this amphiphilic graph copolymer as a biomaterial for tissue engineering in the future. Thank you. I concluded.
Okay. Shreya, your voice is also echoing as PV22.
Oh, I think this might be because of my earphones. I should have maybe disconnected them.
So all the participants are requested that first of all, please check your earphones whether you have not joined it from the two devices. Otherwise, your voice will echo. Okay.
Okay, ma'am.
Okay. So have you published this?
Yes, ma'am. Actually, this one is just recently published this year.
In which journal?
In general, Journal of sorry, I just got. I will tell you. Wait.
Oh, so you don't remember that?
No, I know. It's actually it is the Journal of Polymers and the Environment.
Okay.
It didn't come exactly on my list fast enough. Journal of Polymers and Environment.
Okay, so you have done the preparation of the polymer,
Yes,
and
ma'am.
And then the synthesis, the different grafted polymers you have taken, and then you have measured its percentage grafting, intrinsic viscosity. How have you measured this intrinsic viscosity?
Ma'am, the very basic procedure I have used to understand the hydrodynamic diameter, we have used overall viscometer, and we have taken the timing of going from point A to point B of the various solutions of different grades. And after that, we employed formulas for measuring the intrinsic viscosity.
So that's a viscometer experiment only that the students do in BSc.
Yes, ma'am, the basic experiment.
Okay, the basic experiment. Okay, and
And
thus
we
for
take a solution of
sur-
different percentages. Yes.
and for the surface tension, how have you done?
Ma'am, we have the instrument in our we have facility of this instrument in our campus. So it has a probe which goes into the like just touches the solution of our graphopolymer, and it gives the surface tension, just evaluate measure the it's the DCAT it's called, to understand the contact angle and everything. So there's a probe in our campus facility from where we have measured this surface tension.
Okay, thank you. Next, Sat.
Ma'am, I am audible.
Yes, it's a bit Mr.
Ma'am, I am audible.
Yes, sir.
Yes, yes, you are audible.
Good morning. Good afternoon, ma'am. Respected and dignitaries present over here. My name is Satyajit Misra. I'm from Pharmaceutics. I'm from Pharmaceutics. I am. Sorry, my title. Yes, it's, ma'am, my title of my work is formulation and evaluation of microemulsion emulsion based on jellified system for the topical treatment of onychomycosis. My objective of my research is in order to effective that onychomycosis that goals the current study was developed and assess the potential of microemulsion based on gel squalide carrion moringa oleifera extract. Moringa oleifera extracts are herbal extract. Introduction. The most typical nail infection that affect the nail bed and nail plates is onychomycosis. Onychomycosis is brought on by onychomycosis from a cavity between nail plate and nail plate, allowing from the application drug formulation and allowing detect drug contact with nail plate and nail blades with affected area. Here is my types of onychomycosis. It is a normal cell. It is normal cell and conjunctive agent is dermatophytes and trichophytes and rubon and even that onychomycosis are following types. That is distal and lateral subungual onychomycosis and white superficial onychomycosis, proximal superficial onychomycosis and endonyx onychomycosis, and the last is total destroyed uh, onychomycosis. That's methodology. Microemulsion were prepared after the construction of this pseudotonary phase diagram. Mostly pseudotonary diagrams are optimized to optimize the microemulsion region,
Wait.
that is water and oil are surfactants. After the several pre-formulation trials, Koronja oils was taken as oil phase and Twin 80 and Span 20. Twin 80 are surfactant and Span 20 are co-surfactant are used in microemulsion. And double distillation was aqueous phase which are used in developing the Tournier phase diagram. From the phase diagram, 6 different microemulsion are prepared containing 2% of moringa oleifera leaf extract. Herbal leaf extracts are formulated and evaluated from the particular size and potential, zeta potential and pH. The result of my discussion is by GCMS, the result of moringa oleifera should improve pentatonic acid and methanolic and pentadonic methyl ester, methyl tetracotinate hexacotin acid, and 15 methyl ester were present in extra can work as antifungal microemulsion were prepared and construction is shown on near phase diagram. The main particular size of prepared microemulsion were range 74.23 plus minus 0.3 to 110 plus minus 0.7 nanometer, and the zeta potential was formed minus 0.672 minus 2.01. The observed pH of the all six microemulsion was the range 5.7 to 6.4. Hence, the formulation were non-irritant. All the formulated microemulsion are converted into microgels by adding 2% of carbapol. Carbapol is gelling agent. Carbapol 934 in the external phase. Formulated microemul gels shows the applicable viscosity and rheological property. All the formulation gel showed the significant inhibition against Candida albicans. Antifungal conclusion. The microemulsion based on jellyfied system was found to be safe and effective against onychomycosis. I would like to thank my supervisor, Mr. Yosan Giri and Dr. Amulatun Behra from their guidance.
Okay, Satyajit, you have just read all the text written in the poster. No, but this is not the way of the presentation. Acha, okay, tell me what is an emulsion?
Yes, madam.
Emulsion क्या होता है?
Emulsion W by O and O by W type of emulsion.
नहीं, I am asking what is an emulsion? Emulsion होता क्या है?
Emulsion.
It's a type
ma'am.
of a colloid.
Yes, ma'am.
तो emulsion कौन से type का
Ma'am.
colloid है? What is the dispersed phase and the dispersion medium in this?
Emulsion. Ma'am, two immiscible liquid are present in O by W and W by O.
So this way you will define, like if the dispersed phase
Yes,
and the
ma'am.
dispersion medium both are
Colloid phase.
good phase, then that is called
Yes,
an
ma'am.
emulsion.
Emulsion.
Okay, milk बताओ, milk emulsion है?
Yes, ma'am.
Okay. Okay, but from next time, please don't just read the text from the poster. ठीक है? Prepare for presentation well. Okay, thank you.
Thank you, ma'am.
आगे स्टार्ट करें नेक्स्ट.
क्या सर?
आगे स्टार्ट करें नेक्स्ट वन.
हाँ सर, आगे स्टार्ट करें.
The next one is code PV26 Pritam Pradhan. Pritam Pradhan.
Good evening, sir and madam. Good evening, sir and madam.
Good evening. Pritam, you can share your screen and start.
My title of my work is Formulation and Evaluation of Fluoroconazole Loaded Nail Repair for the Management of Onychomycosis under the guidance of Yashwant Giri and Amulya Ratna Behra, Vishwaranjan Mahanti, and Samal.
Please sit at a silent place.
Yes, ma'am.
ମୁଁ ଜାଣିଛୁ ନା ମତେ ଡର ଖାଇଯାଉଛି ତୁ ଗୋଟେ କ୍ୟାମେରା ଅନ୍ କରିଛୁ ମୋ ଛାତି କଣ ହେଇଗଲା ମୁଁ ଅପୋଜନ ନାହିଁ ଭିଡିଓ ନମ୍ବର ଅପୋଜନ
Sorry, ma'am.
କେହି ବା ଦେଇନାହାନ୍ତି ମୁଁ ବଳ ମୋ ମୁହଁଟା ଦେଖେଇଦେବି.
Sorry, ma'am. Some sound is noise.
Okay, now you can start.
Here is my introduction and the fungal nail infection called onychomycosis. Onychomycosis is a fungal infection of nail unit It is a nail looker that contains drugs developed in the study. The formulation goal to manage an onychomycosis condition. Here is the methodology. Here is the methodology. The formulation part, which we have taken as ethanol plus ethyl acetate as a solvent. In ethanol, we add the polymers like ethyl cellulose, and in solvent ethyl acetate, we add in the polymers as nitrocellulose. Urea, salicylic acid, lactic acid are called as penetration enhancer. Here is my prepared nail liquor and drying time is the formulation, and the result is a complete release 93.07 was seen in the medication released by the prolonged up to 48 hours in the FTIR spectroscopy, IR spectroscopy. The FTR, which contains the drug excipient interaction study. Here is in petri dish, we have taken the drug. The thickness we are seen in the formulation part. In the petri dish, the drug content. In petri dish, the side where the antifungal, which is present. Here is my evaluation part is drying time, solid content, gluconase, thickness, etc. were evaluated. And in vivo part, their antifungal study of formulation, then the stability as per the ICH guideline. And the FTIR study is the drug excipient interaction study in FTIR study, which we taken. And here is my conclusion: the ketoconazole nail looker have an antifungal effect in the drug release of treatment of the onychomycosis. Thank you.
Okay, Preetam, same I want to say for you also, as I have said for Satyajit. Okay, so which way have you characterized? I mean, which characteristic techniques have you used? कोई टेक्निक यूज किया है आपने इसके लिए?
Yes, ma'am. As the formulation part, we take, ma'am, ethanol as a solvent. We add the polymers like ethyl cellulose.
हम्म
And another solvent is ethyl acetate. I have taken as a polymer. We add in nitrocellulose in ethyl acetate.
नहीं, आपने कोई इंस्ट्रूमेंट यूज किया?
Instrument. Yes, ma'am. UV.
अच्छा, यूवी से आपने कैरेक्टराइज किया?
No, ma'am. UV से characterize नहीं किया, ma'am.
फिर कैसे कैरेक्टराइज किया आपने?
मैम characterize के मैम जो मैम solvent लेके ethanol लेके उसके साथ ऐड किया ethyl cellulose as the polymer, ma'am.
अच्छा,
The nail lookup, ma'am, the objective the drug is ketoconazole. When it ma'am, only review, ma'am. Does not take the instrument.
okay, that's just a literature survey.
Yes, ma'am. Literature survey. I'm just working on it.
But your content is very less. Okay, thank you.
Next presenter is with code PB27, Anjali Gopinathan.
Yes, am I audible?
Yes, you are.
So it's visible, right? Poster. Hello.
Yes, Anjali, it's visible now. You can present.
Good evening, everyone. My name is Anjali Gopinathan. I'm a postgraduate student in the chemistry department of Christ College, Irinalakuda. So I did this work under the guidance of Dr. Bina Matthew, who she is an associate professor in MG University. My work is entitled as Green Synthesized Carbon Quantum Dot for Selective Sensing of Chromium-6 Ions. Carbon quantum dots are zero-dimensional carbon nanoparticles with diameter smaller than 10 nanometer. They have recently emerged as promising possibilities for carbon like catalyst, sensing, bioimaging, drug delivery, and so on. Objective of my studies are synthesis of carbon dot, characterization of this synthesized carbon dot using several spectroscopic techniques such as UV visible spectroscopy, IR spectroscopy, and PL spectroscopy, and a final application study. So we chose hydrothermal synthetic route mainly because it's commonly used one-step synthesis in which water is used as a solvent. The apparatus we used is named as autoclave, and this method is low cost, economical, non-toxic, and simple for us. The source that we used here is Naregamia alata, which is commonly known as Nilanarakam in Kerala. It is very popular due to its medicinal properties because it's utilized to cure many diseases such as eczema, itching, jaundice, asthma, bronchitis, and vomiting. So we collected Naragamia alata leaves and were washed thoroughly with distilled water and dried. So we took this 1 gram of Naragamia alata leaves, which is dried, and added 100 ml of distilled water. And using autoclave, we synthesized CDs. The temperature was fixed at 180 degrees Celsius for 8 hours. After completing the 8-hour reaction, the obtained brown CD solution was filtered, centrifuged, and stored at 4 degrees Celsius for further use. So we conducted several studies in order to understand the properties of as synthesized CD solution. First studies was related to physical and chemical properties. So here, an optical absorption spectrum of the CDs was recorded from 200 nanometer to 400 nanometer. Sorry, 800 nanometer. So there was a broad peak around 279 nanometer, which likely reflect to P star transition of conjugated C double bond C domain of the carbon phosphate. As in the second figure, we can see there is an emission peak around 370 nanometer was clearly visible. So the massive blue light emission was likely due to the difference in the particle size distribution and light radiative state present on the surface of the synthesized CDs. In this third structure, it represents FTIR spectra of the CD. Hello.
Some noises are there from your side.
No, ma'am. Can I proceed now? Okay, there is, as we can see, there is a peak at 3296 centimeter inverse. This corresponds to the stretching vibration of ICHE group, and there is a peak at 2067 centimeter inverse and 1634 centimeter inverse. This one corresponds to double bond CH stretching, and this one corresponds to C double bond C stretching. So the other study was based on optimization of wavelength and pH. So as in the first structure, the PL emission spectra of CDs at different excitation wavelengths are presented. The PL emission peak intensities varied with excitation wavelength ranging 320 to 400. So there was a peak at 370 nanometer, and it was the maximum intensity peak. So we considered this as optimized wavelength for this entire study. To explore pH effect, we conducted this intensity test at different pH values ranging from 3 to 10. And it was find out that the highest fluorescence intensity was observed as pH 6. So that was the optimum wavelength and pH. Then we conducted the stability analysis. So the fluorescence intensity and peak position didn't change significantly with KCl concentration range 0 to 2 molar, which means it is stable. And in the second structure, we can see it is also non-affected under UV light. So it's even it comes under the UV radiation, it will be stable. And in the third figure, we can see there is a maximum peak at pH 6, which means the pH of this CD is 6. Then we conducted the application studies in which the fluorescence response of series towards various metal was detected. So here we used neodymium, cadmium, manganese, lead, mercury, terbium, lanthanum, cobalt, copper, nickel, chromium, and europium, in which this CD was detected only chromium 6 ions, which means we can use this as a selective sensor for detection of chromium 6 ions. In the interference studies, we mainly did this study to evaluate the sensor performance of this synthesized CD.
Kindly conclude it.
Okay. So the effect of concentration shows the LOD was 5.69 mMolar. So this CD, synthesized CD, can be used as a selective sensor for chromium 6 ions. Thank you.
Okay, Anjali, what is the novelty of your work?
Sorry, ma'am.
आपने काम जो किया है ये इसमें नया क्या है?
No, this is my project work, so I'm planning to rejoin the team to find further applications.
Okay, so this is some result regeneration?
No, ma'am, this is a new work.
Okay. Okay, thank you.
Thank you.
Okay, Anjali, the next presenter is Pratiksha Mohanty. Pratiksha Mohanty, are you there? Yes.
Hello. Yes, sir. Am I audible, sir?
Yes, you are.
Okay. Can I present my slide, sir? Hello. Am I audible, sir?
Yes, you are audible. You can present.
Is this visible, ma'am?
Yes, it's visible.
Good evening to everyone. I'm Pratiksha Mohanty. I'm a PhD student. I'm doing my PhD under the supervision of Dr. Kalpita Bhatta. My topic is basically, ma'am, it is a review topic, and I'm going to literature review about, and it is my slightly PhD topic, and I'm just reviewing about this data, the formulation in vitro and in silico characterization of the curcumin gel for the treatment of the periodontitis. Ma'am, here I do only the in silico work, and after that I am decided to designing as a drug delivery system. Can I proceed, ma'am, further?
Yes, you can proceed.
Ma'am, aim of my work is to present or investigation was study the in silico activity of the curcumin to determine the anti-inflammatory activity by using carbapenem-based curcumin gel. Ma'am, here carbapenem I'm using because it has a strong adhesive properties, and when carbapenem used as a gel formulation, it is attached to the tropical surface of the skin. which helps to healing the wound. Next, ma'am, the objective of my study. Here I use curcumin because as we know, curcumin is act as a anti-inflammatory agent, because here we use curcumin. Curcumin having the anti-inflammatory agent because it increases the fibrinocytosis. So, ma'am, fibronectin is one type of protein which have the activity to tissue regeneration or tissue formation. Ma'am, as you know, it is like periodontal disease. During periodontal disease, when there is a formation of gap between the roots inside the root pocket, at that time, ma'am, we use the gel formulation of the curcumin, where there is a strongly formation of the fibronectin, which is further proceeding to the regeneration of the tissue and healing activity of the disease. Ma'am, here I use the gel formulation by evaluating the various properties such as compactability, drug content, viscosity, and in vitro drug release. These are my formulation I am using in this experiment, ma'am. In further, ma'am, I use the methodology here, that is DSC or FTIR analysis. Ma'am, DSC is used to the for the study. For the DST and FTI study, I am using in this experiment, ma'am, because here there is a binding affinity of the curcumin for the major inflammatory mediators such as cytokinin, chemokinin, which is signaling proteins, and the transcriptional factors, which is evaluating by using the docking. And this is my docking part, ma'am, which is I'm do. Here is the different type of protein, like I said, I'm used as a comparative study, ma'am, like different type of inflammatory mediators, that is ERK, PKC, P38, MAP kinase, NFKG, and lipogenase, ma'am. Here I found that P38 MAP kinase is so good binding affinity as compared to the other inflammatory. Here, there is a good binding affinity of the P38 MAP kinase towards the curcumin, which is I use as a ligand. And these are the docking score. Here I use lipogenase, which is a formulation minus 9.3, and PKC is minus 9.7, and ERK is minus 8.0, ma'am. Here P38 MAP-K1 NAZ, which shows a good anti-inflammatory activities towards the curcumin. So these are the formulation value, ma'am, where F3 show the good formulation, and these are the formulation code. As I am showing that there is a good binding affinity towards curcumin towards P38 MAP kinase. So I'm decided to further formulation formulation use like is as a nanogel formulation. And Carpapol 934 ppk based curcumin gel is suitable for this formulation as the given result, ma'am. Thank you.
Okay, Pratiksha, it's a computational study, means it's a in silico study. Okay, so you are studying the protein ligand interaction where your protein is curcumin and you have selected it for the different ligands. Is it like this?
Ma'am, it is like I'm saying that, ma'am, it is like a normal review, ma'am. And I'm just going for a literature review, and I'm collected the data, but after that I'm not know
No,
how.
but you are studying the protein ligand interaction. So which is your protein and which are the ligands?
And just want to know about which having the good binding affinity, so that I'm for
So good binding affinity of the ligands of different ligands with curcumin. Is it like this?
Yes, ma'am.
Okay. So you have calculated the docking score. You have not calculated, I mean, you have taken the value from the literature. Okay.
Yes, ma'am.
Acha. So from the literature, you have written this docking score. So have you checked how have they calculated this docking score or which software they have used?
Yes, ma'am. I'm using Autodoc Vina 1.557 and Pymol.
Autodoc. So you have
And
regenerated.
also, ma'am, BioBlood Drug Discovery Street I'm also using.
So you have regenerated these values and compare it with the literature, or you have
Yes.
directly you have not
Ma'am.
used this software.
I'm compared with this other literature, ma'am.
Okay, so you have done this docking.
Yes, ma'am. And it is my own, ma'am. Lastly, I'm just tell you that COX-2 in literature, COX-2 having minus 7 point value is there, ma'am. So that I'm decided to docking with P38 MAPK1 kinase. So for the normal study, who is having the good binding affinity. But as compared to COX-2, P38 MAP kinase showing a good result, ma'am, minus 9.3. So,
Okay. So in the literature, these values are available for
yes,
with
yes.
So
No, ma'am.
your values
Literature-
coincide.
Yes, ma'am. Actually, literature there are separate value, ma'am. I am doing it own, ma'am.
No, you are doing it on, but is it matching with the literature? Or you
Yes,
can
ma'am.
say that your results are in agreement with the literature?
Yes, ma'am.
Okay, so there is no novelty in this work. You have just reviewed the work done by others.
Ma'am, actually, in literature the value is different, ma'am. And
Okay.
I'm saying you the means it is the good value that previously in last literature there is no evidence about it, but it is my own work and there is a good result of binding affinity towards it. That's why we have decided to if we are going for this formulation, that should be a good result in future, ma'am.
Okay. So, I mean, you are confident that your
Yes, yes,
results are better in comparison to the results given in
yes,
literature.
yes, ma'am.
Okay. Okay, thank you.
Thank you, Pratiksha. The next presenter is
Good evening, sir. Yes, sir.
Isri Das.
Hello. Yes, sir. Hello. Sir.
Pratiksha,
Yes, sir.
you can leave it.
Okay, sir. Thank you.
लीना मैम और कोई क्वेश्चन नहीं पूछना आपसे?
नहीं सर, हो गया नेक्स्ट.
Thank you, ma'am. Thank you, sir.
The next presenter is
Good evening, ma'am. Am I audible?
Yes, you are audible.
Good evening, ma'am. Myself, ICHE-2023 Das. I'm a PhD scholar from Birla Institute of Technology, Mishra, and I'm working under the supervision of Dr. Trishna Bal. So today I'm going to present a poster that is based on the synthesis and characterization of interpenetrating network of carrageenan and gelatin using freeze and thaw cycle. So here I am using that. I have prepared that interpenetrating network of two polymers, that is carrageenan, and another one is gelatin. This carrageenan was this is derived from the red seaweed, and this is basically a polysaccharide. It is basically known as sulfatal polysaccharide. It is composed of several monosaccharides like galactose, lactose, arabinos. Those are linked by the 1,3 beta glycosidic linkage. And this carrageenan is known for its biocompatibility and biocompatibility nature and tissue regenerating nature. Means basically it is used in the tissue engineering. And the gelatin, it is derived from the animal protein collagen, and it does have also the biocompatibility nature, and this is non-toxic. Both the polymer, that is carrageenan and gelatin, they are known for gelation and the thickening, then emulsifying and film forming agents. But carrageenan do have a very good promising characteristic, that is thermo-reversible property. For this reason, I have taken this carrageenan. So I have prepared one interpenetrating network. So this interpenetrating network is one kind of novel drug delivery where one polymer is going to cross-link in presence of another, and in IPN, the characteristic or the property of both the polymers are reflected. So here I have used one green technology, means that is free-young Thaw cycle. I haven't used any type of chemical here. Since the chemical does have the toxic nature, it can harmful to the body, and so I have prepared the interpenetrating network of this two biocompatible polymers via freeze and thaw cycle, and went for the characterization studies like swelling test, FTIR, DSC, is in vitro biodegradability test, biocompatibility test, along with the drug release study. So basically, my focus is based on the drug release behavior, means release of drug from the interpenetrating network. So I have taken here the model drug, that is the tabudine, which is used for the HIV. So here I have prepared the IPN. This is the fill. So and here I have what happened in this case. I have just taken the polymer blend of both the polymers, then put it in a water, since both are water soluble, then kept it in a temperature 70 to 80 degrees centigrade, and styling for 24 hours. Once once a systematic or the homogeneous mixture was formed, then I went for the drying. I just semi-dried the formulation, then casted it over the petri dish, and wait for the freeze and thaw for 5, 10, and 15 days. So what happened then? According to my characterization test, when I went for the swelling test in different pH, since I found that my prepared IPN is sensitive to stimuli like pH, I have chosen 3 pH. One is 1.2, 7, and 8.0. 1.2, 7.4, and 8.0. So I found that my formulation was showing a better result in pH 1.2 due to presence of the group which is present in the polymeric chain of both the polymers. In why it is shown better swelling in pH 1.2, because it was observed that most they possess COH group, which is being ionized in pH 1.2, so that lead to increased swelling. So in FTIR, here the FTIR of since I am considering, since my focus is on the drug release behavior, I have taken the FTIR of this pure drug and the drug loaded IPN. So so this is you can find that here the groups of the pure drug is reflected in the drug loaded IPN, which clearly indicated that there is a drug and polymer, there is drug and polymer compatibility. Next is here I have taken the DSC. I performed the DSC. Why? Because to know the thermostability nature of the drug loaded IPN, and I found that the peaks, they are having very less difference between them, which also confirm that there is no interaction between the drug and polymer, means the drug is appropriately reflected in the IPN. Now, the same image of the drug-loaded IPN, this one is the same image. So here we can clearly observe that the drugs are they are easily appeared at the surface of the IPN. That means the drug, that showing that drug is efficiently loaded in the IPN. And now The biodegradability test was done by taking the Bacillus subtilis culture, and it was found that after keeping the IPN inside the Bacillus subtilis culture, the weight of the concerned IPN, it was just losing day by day, and finally at the end of 30 days it totally loses its weight. So that means it is biodegradable in nature. Then hemocompatibility test was also done with human blood, and it was found to be 0.51%, which clearly evidented that the drug is biocompatible. The IPN is biocompatible in nature. Now come to drug release study. I have performed the drug release study. Simply, I have taken the IPN, drug-loaded IPN, and put it into the pH 1.2, and the temperature was maintained at 37 degree for some time. Then I have taken the supernatant, then I have collected the sample after a certain interval time and go for the measuring. Yes, sir.
Kindly conclude.
Yes, sir. Go for measurement of its adjuvants at 265 nanometer. Then I found that the percentage of drug release, it is at the end of 8 hours is 85.59%, and the total drug release process, it follows the non-frequent diffusion along with it follows the zero order kinetics. So finally, it is concluded that the IPN, which I have just developed, that is biocompatible, biodegradable, and it is released in a controlled release fashion, and it is suitable for both tissue scaffold and drug delivery vehicle. Thank you.
Okay, so what you have said in the last, that like it's biodegradable, it's biocompatible. So this is the novelty in this IPN.
Ma'am, actually,
I mean, no other person has done that.
yes, ma'am.
So your work is novel. So have you published this?
No, sir. No, ma'am. I'm going to publish this. Some works are still it is there. Those I have to go for go for carrying out. So once those tests were performed, then I'll surely go for publication of this.
Okay. Okay. Thank you.
Thank you, ma'am.
So the next presenter, Sumit Kumar Das with code number PB30.
Good afternoon, sir. Hello.
Yes.
I'm audible, sir?
Yes, you are audible.
Good afternoon, all. My topic is immunomodulatory potency testing of ethanolic extract of bags of Saraka indica. There is an increase in disease, especially infectious diseases, that requires efficient body defense mechanism to control them through the process of immunomodulation. Inadequate balanced dietary intake, most especially proteins, and diseases are immediate cause of malnutrition, and this reinforce on other synergistically uh, allopathic drugs used to modulate the immune system are very expensive for poor people. They are not easily accessible, and in the most case, they are associated with adverse drug reaction. The main objective of this study is uh, to how to boost the immune system from the Saraka indica. But the immune system is our most pivotal and its main function to keep us healthy and robust. If we eat foods which are completely pure and full of vitamins, enzymes, and minerals, our immune system will be able to constituents battle against viruses, harmful bacteria, parasites, and toxins. The idea of boosting our immunity is exciting, but the ability to do so has proved elusive several lesions. the immune system is precisely that a system, not a single entity. To function well, it requires balance and harmony. There is still much that researchers don't know about the that inter
Yes, Sumit, you are not audible.
सुमित, आपकी आवाज नहीं आ रही है। लगता है कुछ नेटवर्क इशू होगा। लीना,
हाँ सर, नेक्स्ट ले लेते हैं फिर।
ठीक है। The next presenter is postal code PV31, Abhinav Kumar. Abhinav Kumar, are you there? मुझे लगता है मैम he is absent.
Okay, then next.
The next and presenter is Chinmay.
He is also absent, I think.
Then we will move to the second presenter, Naveen Kumar. Naveen Kumar.
Yes.
Now you can present your topic.
Okay. Hello.
Yes.
My poster is. Can you display?
Yes, your poster is visible, but please share your screen as slideshow.
Okay, ma'am. Okay. My name is Naveen. I am from Banaras Department of Chemistry from Banaras University. My topic is a multi-component reaction of CS2 amines and sulfoxamide.
Why it is so blurred?
Yes, ma'am.
Please zoom this. Zoom this.
Okay, okay.
Just right click, there will be an option. Here you can zoom, huh? I don't know why.
Fine.
Now it's visible.
Okay. And my topic is a multi-component reaction of CS2 amines and sulfoxamide in water. Straightforward access to beta-ketothiocarbamates, thiazolidine 2 and thiazolidine 2-thione. Introduction. Organic dithiocarbamate skeleton are found abundantly in various bioactive molecules and represent an important class of sulfur-containing compound. In addition to their excellent anti-cancer activity, they are important to the rubber industry as well as in agriculture industry. Uh, uh, Additionally, the thiazolintone and thiazole 2-thiones moieties also generally exist in various natural products and bioactive compounds. Due to their vast array of application, the synthesis of beta-ketothiacarbamates, thiazolindine 2-thiones, and thiazole 2-thiones derivative have been recently attracted a great deal of attention in the literature. As carbon analogs, the beta-ketosulfonamide have recently been widely used in chemical transcription due to their accessibility, stability, and diverse reactivity profiles. Numerous points studies utilization transforms metal catalysts to synthesize different heterocyclic and different heterocyclic or carboxylic molecules have been reported. Our fundamental research was synthesize beta-ketothiacarbamates. We usually choose the model substrate elide and CS2 to morphine to determine the best condition of, to determine the best condition for the optimization. Presently, we are surprised to find a model substrate in DMSO at room temperature to furnish beta-keto dicarbamates for after 4 hours with a yield of 60%. We also examine other protein solvent as well as a protein solvent. We find that the water and methanol protein solvent absence of to determine it would be an increase the yield of target molecule. We noticed that water had the highest yield after evaluating all the option, and it reaches completing this in 6 hours with nearly quantitative yield of a compound in uh, 90% of use when we use the THF at water in 1:1 reaction. In addition, we explored the opportunity to synthesize of a thiazolone 2-thione 6 and thiazole 2-thiones diabetes 7 form sulfur-oxygenol. After being motivated by the approach for synthesis of beta-ketothiacarbamates described above, for our initial attempt to react model substrate elide 1A with CS2 and ethylamine 5 in water to afford the thiazolone 2-thiones 6A in 93% yield. To assess our potential and broad application of this approach, representatively primary amine 5A with the CS2 were screened with elide 1 and the result are represented in the scheme. This scheme which afford the aliphatic as well as aromatic compound to evaluate the beta ketothiacarbamate thiazolone. We synthesize some bioactive compound. We synthesize some bioactive compound as in this to evaluate the synthesis application of isolated thiazolone 2-thiones and derivative. We also carry out a gram scale reaction. It is now time to suggest a possible mechanism after remarkable demonstration of the practical synthesis of beta-ketothiacarbamate, thiazolone and thiazolone 2,7 derivative from sulfoxime elide. The proposed reaction mechanism for the synthesis of this scaffold as in the schema. Which the chemical reaction of CS2 with a primary or secondary amine result in the formation of dithiacarbamates with the alpha position of beta-ketothiacarbamate 1 and lead to the formation of intermediate 1. Then are converted into beta-ketothiacarbamate 4 and second with the release of DMSO as a leaving group in the presence of secondary amine. The intermediate second subsequently cyclized to afford a thiazolone 2-thione derivative 6. However, in acidic condition environmental, the thiazolone 2-thiones 6 dehydrated to form thiazolone 2-thione. thiazolone 2000. In conclusion, we have developed a versatile and catalyst-free straightforward synthetic mechanism of beta-ketothiacaramide, thiazolone 2000, and thiazole to derivative form easily accessible beta keto sulfoxamide with CS2 and primary as well as secondary amine. Our synthetic approach offer a great synthetic opportunity for a number of functionalized NS nitrogen sulfur heterocyclic and generally work well with a wide range of primary or secondary amine with this simple operation procedure. Thank you.
So Naveen, you have done this organic synthesis
Yes, ma'am.
of beta keto dithiocarbamate.
Yes, ma'am.
Okay, so what is the is there any biological importance of this compound?
Yes, ma'am. These compounds are used in rubber industries, agriculture industry, and this is also used in anti-cancer activity.
Okay, anti-cancer activity. So have you checked any anti-cancer activity?
Yes, ma'am. We synthesize a gram scale reaction as well as we report a chalcone derivative in the application. This chalcone derivative also used in a bioactive compounds, ma'am, for anti-cancer activity.
Okay, so what is the novelty of this work?
Ma'am, this first of all, this our approach metal-free catalysis, and our solvent is water, which is universal solvent. We don't and reaction perform in under our direction, our room temperature, and time will reduce completely in 6 hours.
Okay. Okay, so have you published this?
Yes, ma'am. Recently, our work published in GOC, ma'am, April 2023.
Okay. Okay. Thank you.
Thank you.
I think there is a end of presentation. Now, on the way of ICHE-2023, I thank you to all the participants, and a special thanks to our chairperson, Dr. Leena Agarwal, which is share your valuable time with us. Thank you very much, ma'am.
Thank you, sir.
Thank you, sir. Thank you, ma'am.
Have you got your evaluation sheet?
मेरे को कहाँ शेयर करनी है सर इवैल्यूएशन शीट?
I will tell you the discussion होगा. I will tell you. You are is with you, na?
ठीक है.
Yes. Thank you to all of you.
So can we leave now, sir?
Yes, sure.
Oh, okay.
मैं फोटो भी खिंचाना है क्या? हो गया? हाँ हाँ हो गया.